Adjacent angles. First, let's define it, then let's talk about it. So here's what adjacent angles are. Holy moly! Two angles that lie in the same plane and have a common vertex and a common side, but no common interior points. So you can pause the video and write that down for yourself. What does it mean? Adjacent angles. First, two angles. It could be more. Well, no, it's just two. Sorry, two angles. So I'm going to highlight one of them. You see? Angle 1 right there that I have highlighted. Okay, if you want to highlight along, highlight along. You also see angle 2 right here. Those are adjacent angles, and let's realize why. First of all, they're in the same plane. We'll always assume that unless they show us three-dimensional pictures, but we're in the same plane, so check, we got that done. Do they have a common vertex? Isn't that point the vertex of both of them? Do they have a common side? Did I highlight one of those rays? See, it's important to know what sides of an angle are now. Isn't that the rays that make up that? Did I highlight one of those rays, both blue, well, I didn't use blue, both green and red at the same time? Did I do that? That'd be this one right here. Isn't that common to both of them? Then this is the tricky part. There's no common interior points, meaning if I shaded the green one in, like isn't this all the interior, correct, of the green one? And all the red one, if I shade that in, did I ever highlight red on top of green in those interiors? Yes or no? I did not. Okay? Now let's go to an example to where they're not adjacent angles. You can see over here there's non-example. Angle 3, right? And the other angle they talk about is angle ABC. Whoa, isn't this angle ABC, right? Now first let's go through it. According to the rule, do they have a common vertex? I believe they both have B for a vertex, right? Do they have a common ray? Do they have a common ray? Didn't I highlight ray BC, both red and green at the same time, correct? Now, do they have no common interior points? Well, let's see. Let me highlight the red one first. Isn't this all the interior of the red dude right there? Cool? Now let me, all the green one. Isn't that the entire green one? Did I ever have some interior of the red and the interior of the green on top of each other? These are not adjacent. Isn't that red angle completely on the inside of that green angle? Okay? Now let's break it into real world things about like adjacent classrooms. My classroom and Mrs. Colwell's classroom, which is right next door, they are adjacent because don't they share a wall in common, right? They are totally touching each other. Cool? But my classroom and Mr. Peterson's classroom is where I was last year, which is across the hall. Is there any wall that's common to either one of those? They're non-adjacent. They're not touching in the first place. Now, what about my classroom and this closet? The closet is sharing this wall, but isn't this closet inside of this room in the first place? They are also not adjacent. They have to be two totally separate rooms that can only share a wall in common. This is like two totally separate angles, but isn't this red angle inside of the green angle? It just doesn't work. So in our own words, adjacent means they are touching, but only at like a common ray kind of where they're not inside each other. So angle 1, boo boo. Angle 2, red. Boo boo. You see how if you shaded them both in, there would not be any interior common points, but they do share one. This guy, angle 3, boo boo. And angle ABC, boo boo. Do they even touch each other in the first place? They are non-adjacent angles. So adjacent, for our own words, means they're touching, okay? But they can't be inside each other. Sound all right? All right, so let's do this. Let's draw acute angle 4 and obtuse angle 5 as adjacent angles. Sound okay? So one thing at a time. First of all, should they be touching each other? They better be, right? Let's start with acute angle 4. So how much should it measure? Less than 90. Can you just kind of guesstimate? I don't need a protractor necessarily. Can you just kind of guesstimate? Wouldn't this be 90 degrees straight up and down? What if I did this? Would that be acute? For sure. We could put a protractor on it and it would be acute then, correct? So just do that, and it needs to have a 4 on the inside of it. Sound okie dokie? Now, angle 5 is supposed to be obtuse, so it doesn't have to be bigger than 90. but it's also got to be adjacent to this, so don't we have to share one of these guys in common? Which one do you want to share, that red one or this blue one? Because it doesn't matter. Which one do you want to share? Blue one would probably be much easier because it kind of points to the right. So let's share with that blue one, and we'll just kind of draw with our straight edge, if I can find my straight edge, off of it. I just need to look at it, maybe turn my paper a little bit, and realize this would be where it is right, nice and straight up and down. If you turn your paper, I need it to be obtuse right there. So angle 5. If you want to use your protractor and measure, use your protractor and measure. But there's angle 4, it's acute. There's angle 5, it's obtuse, and those two are adjacent in the first place. Feel okay with that. Next one, draw angle 6, excuse me, angle 6 and angle 7 as non-adjacent angles. Give that a shot with PAL. Pause the video, get that done. That is by far the easiest way to draw non-adjacent angles. Were they ever touching in the first place? Don't make it any more complicated than it has to be. Non-adjacent, sure, you could try to draw stuff like this guy or this dude inside another one, but that's complicated in my opinion. Non-adjacent, I don't want them to touch each other. Coop, let's roll on. Complementary angles. You heard of that before? Complementary, supplementary, you heard of those two words? What does complementary mean to you? Yes. Complementary, the two angles whose sum is 90 degrees. Two angles. Notice how I put that in all capital letters, because that was like important. It's only two angles whose sum is 90 degrees. So let's draw a pair of adjacent, so they got to be touching each other, right? Complementary angles 1 and 2. Well, let's think about the whole goal. If they're complementary, when we add them together, what will it look like? 90 degrees. But they got to be touching each other, so when we put them together, won't it look like a right angle? So let's start with a right angle. Let's do that. Let's start with a right angle. Sound okay? And then I need, that's a horrible looking right angle, sorry. Do we need a box? That's a good question. Not necessarily, because we're going to put more info in it. If you have a box, it's not wrong. Like, don't get me wrong, okay? But what I wanted to show you next was, aren't we going to put more info in this picture? So I need to split this into two angles, but they're supposed to be touching each other. So that means we've got some sort of ray in here. Does it have to bisect it? Do they have to be 45 degrees and 45 degrees? They didn't tell us it was bisecting, right? Could it be 30 degrees and 60 degrees? Could it be 50 degrees and 40 degrees, right? So does that thing have to go smack dab right down the middle of it? So let's not make it down the middle. Let's put it like right there. Wherever, you know. But one of them's angle 1, the other one's angle 2. Are we down with that? Yes, no, maybe? Now, how do I know that they're complementary? I got to make up some angle measures. I didn't even measure it, right? Didn't even use my protractor. If you want to, you can. But make up something for this angle. What do you want it to be? 30 degrees. Cool? Now we have no choice of what the other one has to be. If this is 30 degrees, what does that one have to be to make them complementary? 60 degrees. And do you see how now you don't necessarily need the right angle box. We can see that it adds up to 90 degrees in that situation. Cool? Let's draw a pair of non-adjacent complementary angles, angle 3 and angle 4. Non-adjacent. Let's make it easy. What does that mean to us? Non-adjacent. Not touching. So let's do angle 3 first. Use a straight edge, of course. Doodly-doodly-doodly-doo. There's angle 3. And let's just do our best guesstimate. The only time they really want us to use a protractor is when they tell us to use a protractor to measure something or anything. If they say, please make a 50-degree angle, then you use that. So what do you want that to be? About how much? What does that look like to you? 40 degrees sounds great. Okay? Got to have a 3 in there. Now we know our other one can't touch it, right? It's like MC Hammer. Woo, that's old. And it's going to be angle 4. And how much should it measure if they're complements of each other? 50 degrees. 50 degrees. So those non-adjacent complementary angles. Feeling pretty good about those concepts. So if we know what complementary means, the word complement is very, very similar to it. The complement to it. Just like what I kind of was doing right here, if I cover this up for a second and I said, hey, we drew a 40-degree angle and we need another angle to be like complementary, and this was 40, what was the other one? 50. That's called its complement, the other angle that makes it add up to 90. So in the problems below, an angle measure is given. Find its complement. If they give me a 30-degree angle, what's the complement to that going to be? This is what you would still need to make it add up to 90, right? That's the complement to that. How about a 21-degree angle? So wouldn't I need to get 60 more to turn that into an 8, and then a 9 right there to turn that into a 10, 69 degrees? How did we get that real quick? Let's say I didn't have the greatest mental skills. What could you do? Like, how did we get 60, really? 90 minus 30, right? How did I get 69? How could I get that? 90 minus 21. So 76 degrees. Don't we need 90 minus 76, which is how much? Is it 24, or is it 14, or is it 4, or what is it? Pretty sure that it's 14. With me? Get 8 done for me. What's the complement to an 89-degree angle? What is it? 1 degree. The complement to a 110-degree angle. What does complementary mean again? They got to add up to equal 90 degrees. So to go from 110 to 90, I would need negative 20 degrees. Can that happen? Can an angle have a negative measure? So what's the complement to a 110-degree angle? There is none. It doesn't have a complement. Not every angle in the world has a complement. It's more than 90 in the first place. Sound cool? And now here's what I was trying to set us up for. This will save our lives on Thursday, if we can figure this answer out. Let's go through the process one more time. How did we get 60 degrees? We did what? 90 minus what was given to us? 30. Wasn't this answer 90 minus 21? Wasn't this answer 90 minus 76? This answer was 90 minus 89, right? This answer couldn't be done. If I give you an x degree angle, what is the complement to it? This one was 90 minus 30. This one was 90 minus 21. This one was 90 minus 76. This one is 90 minus 89. So any angle that I give you, how do you find its complement? 90 minus x as a quantity, degrees. It's not x minus 90. It's 90 minus x, right? Just put in for whatever you want x to be. Now, sometimes it can't happen because that's bigger than 90. But in general terms, the complement to any angle is 90 minus that angle measure. Sound okay? That's complementary. 2 angles. Supplementary. If complementary is the sum of 2 angles equaling 90 degrees, do you have a wild guess of what supplementary would mean? It'll still be 2 angles that add together, but they won't equal 90. How much will they equal? 180 degrees. 2 angles whose sum is 180 degrees. The problem that we have now is we get messed up with complementary, supplementary, 180, and 90. It's like, oh my goodness, I can't remember which one goes with which. Here's a little secret that I've learned over my years. If I put the 2 numbers in numerical order, doesn't 90 come first before 180 if I put them in numerical order? Cool? If I put the 2 words complementary and supplementary in alphabetical order, doesn't C come before S in alphabetical order? They match up. Complementary goes with 90. Supplementary goes with 180. Complementary comes before supplementary in alphabetical order. 90 comes before 180 in numerical order. So I just realized, oh, well, complementary and 90 come first. They go together. Supplementary and 180 go second. They go together. Does that kind of make sense to you? So draw a pair of non-adjacent supplementary angles, 8 and 9. Show me. Should they touch or should they not touch? Not touch. Let's start with angle 8. Draw whatever you want it to be. Angle 8. Right there. Got her drawn. Now let's guesstimate how much it is based off your drawing. To me, my angle looked like 45 degrees, so I put 45 degrees. Now I need to think of the other angle that makes it add up to 180, which would be called its supplement, right? If these are supplementary angles, supplement. What's the supplement to a 45-degree angle? You can use a calculator. How would you figure it out? 180 minus 45. What do you get? Anybody? 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 135 degrees is what mine should be. What kind of angle is that? Acute or obtuse or right? Someone make it look obtuse. How come I didn't make them touch? Non-adjacent. So based off whatever your numbers were, make sure that those two angles, they're not touching each other, and they add together to equal 180 degrees. Excuse me. And how many angles did I even draw in the first place? 2. Now I want to use a little bit of thinking. Okay? Next thing they want us to do is draw 2 adjacent supplementary angles. Right? Adjacent supplementary angles. Should they be touching each other? And they add together to be how much? 180. What happens when angles will touch each other and add together to be 180? Just like back here, way back yonder, didn't these touch each other and they added together to be 90? It formed a right angle, correct? If you have two angles that add together to be 180, but they got to touch each other, a shape will appear. Anybody know what shape measures 180 degrees? Not necessarily. So we didn't know, so let's try one. Let's draw angle 6. Let's make this dude point this way. And let's just go, let's kind of make it about, real easy number to deal with. How about 30 degrees? Would that be okay? Just make it roughly about 30 degrees and put a 6 inside of there. But I need a supplement. And they got to be touching, right? They got to be touching. So what is the supplement to a 30-degree angle? First of all, how much do I need? 150, right? But it's got to be touching it, so doesn't it have to basically start from this ray right here? So we need to start from there. And it's got to be 150 degrees. And 150 plus 30 is 180. And something will appear that makes 180 degrees. Here's what it'll look like when we're all said and done. It'll all look like this when we're said and done. This will be the 150-degree angle right there, angle 7. See this shape right here? What is that? That's a line, baby. 180 degrees is a line right there, 180 degrees. So when we draw adjacent supplementary angles, they will always form a line. Does that kind of make sense? Because they have to add together to be 180, and they have to be touching each other, so they will form a line every single time. Cool? Why don't you find the supplement for me right here, since we kind of already know how to do that. You and Pal get all of those done. 180 minus x. Should it be in parentheses? Yes. Where does the degree symbol go? Out there. 180 minus x. That's the general case. Did we have any situation? We'll talk about perpendicular. And what's perpendicular mean? Two lines, rays, or segments that intersect at a right angle. Two lines, rays, or segments that intersect at a right angle. In a picture, you might see a symbol in a picture for perpendicular that looks like this. Oh, symbol in a picture? My bad. Whoa, whoa, whoa. Symbol in a picture is the box, the right angle box. The right angle box. If you're in a picture, you see that symbol right there? The right angle box is that. Now, the symbol in a sentence, like if they had something in like a math sentence, looks like this, an upside down capital T. Upside down capital T means perpendicular. What does parallel mean? Remember that, parallel, in your own words? What's parallel mean? They never intersect. That's as far as we know so far. It's not totally right, but we'll clean that up another day. But parallel lines, they don't intersect. Okay, they have to be in the same plane also, is what the real part is. So let's see if we can translate this English sentence right here, underlined in green, into a math sentence. See this? Line AC, how it says that in English? Translate that to math for me, please. How would we write line AC in math? What does that say? Distance from A to C. Is that what we wanted to say? What does that say? Segment AC. What's that say? What's that say? So that's how you translate line AC into math. Then is perpendicular to. So this is a sentence, correct? We need the symbol in a math sentence. Should we put the right angle box or should we put the upside down capital T? Boom. And then line BD comes next. That's pretty simple. Isn't that just like that? So That right there is taking the English sentence of line AC is perpendicular to line BD and putting it into straight, old math symbols right there. Cool? So, let's see what this says. It says, find the value of x and y so that, how would you read that out loud? Line NR is perpendicular to line MQ. It's one of those things, if you don't know what the symbols mean, you're not going to know how to do the problem. Cool? So, they're saying line NR, I'll find it for you. Let's do a little finding. Isn't this line NR right here? I want it to be perpendicular to line MQ. Well, if they're perpendicular, what do you know about them? They intersect at a 90-degree angle. They say, please find the value of x and y. So let's find x first. Here's a 5x. Here's a 1x. This is supposed to be 90 degrees if they're perpendicular, correct? So what kind of equation can we set up to do that? 5x plus x equals 90. Would you agree with that? Let's combine like terms right away. What's 5x plus x? So over here, nice, neat, and organized, 6x plus, I guess there's no plus. 6x should equal 90, correct? Right, because we did 5x plus 1x equals 90. Now let's solve for x. See if that comes out nice. Wouldn't you divide by 6? Does that come out nice? What do you get? 15? Is it 15 degrees? Or is it just 15? It's just the value of x, right? Once you substitute that back in, it would give you a degrees after you do that. So x is just 15. Cool? Now let's find y. Isn't there a y in the picture also? Here's some y's. What can we do with that guy if they're supposed to be a perpendicular? 9y plus 18 equals 90, right? Because isn't that whole overall bad boy supposed to be 90 degrees? Solve for y. Pause the video, get that done. So hopefully we got y equals 8. Feel comfy with that problem. Next, see this inflammation? See that picture right there? Let's see if you can put all that inflammation into that picture right there. Pause the video, get that done. Just put the info in the picture, then we'll do the rest together. So we needed the 3x plus 10 in the picture, we needed the x in the picture, and then you also must put the right angle box in the picture because they tell you they're perpendicular. Now see if you and Pal can set up an equation and solve for x. This is a 90-degree angle right here, correct? Isn't that a 90-degree angle? Highlighting helps us see. So see if you can set up an equation and solve for x. What do you think about 4x plus 10 equals 90? Where did 4x come from? Combined like terms, right? I'm adding x plus 3x plus 10 equals 90, so 4x equals 100 or 80? Because you got to subtract 10, and x equals the 20. Is that right? Cool. Is that all they want? Yes. Now let's see if we can kind of preview for chapter 2. You know how we were like justifying where these equations came from and all this? Why did we write this? Why did we say that this should all add up to equal 90? There's like one juicy thing in here that was like the most important. Perpendicular, right? And would you believe that that's like what perpendicular means, that should be 90 degrees? So there's no theorems about perpendicular, and there's no postulates about perpendicular. It's like the meaning of that word, like the definition of perpendicular. Is that pretty cool with you? That's our justification. You can use definitions, postulates, or previously proven theorems. That's exactly what perpendicular means. Number 4. Same thing. Put it all in the picture and get her done. Pause the video. Are we cool with all that? Did I put everything in the picture correctly? It's a kind of maybe, maybe not, because they didn't straight tell me that they were perpendicular. They said find the value of y that would make them perpendicular, right? So it's like if y was 9,